All right, let's start section 5.1. 5.1 is about normal curves, which we've already started looking at, and then changing them into standard normal distributions. I split this section up into two, so there'll be two videos, 5.1 part 1 and 5.1 part 2. This is a chart from the book. Not saying that you have to memorize all of this, but let's talk it through. We know a lot of it. The first thing is that the mean, median, and mode are all equal. We know mean, median, and mode. I know we've all slept since then and it's crazy, but remember, mean is the average. Median is the data point that's in the middle if you line them all up in numerical order, and mode is the data point that shows up the most times. So this curve is bell-shaped. It's also symmetric. So remember, symmetric is that if I fold it on the middle here where the mean is, my pen is not wanting to work. Let me see here. Well, we'll work on that in a minute. Right now, if we fold it over in the middle where the mean is, the left-hand side would land right on top of the right-hand side, right? It's the same on both sides. Also, this blue part, the area that's under the curve would be equal to 1. If we're looking at percents, then that would be equal to 100%. We're going to talk about inflection points in a few minutes. Okay, this just shows that the bell curve can change. It could be taller, it could be shorter, it could be wider, it could be more narrow, and that's all going to depend on the mean and the standard deviation. So you can see A is a little wider, and that is because the standard deviation is 1.5, whereas the B right next to it, the standard deviation is only 0.7. Therefore, the data is more diverse and more varied on the first one because the standard deviation is 1.5. And so as we add and subtract the standard deviation, the bell curve is going to spread more. Whereas in the middle, that graph has 0.7. It's a little more narrow. They both have the same mean though. So notice they both have a mean of 3.5, and therefore the middle of the curve is right there at 3.5. Now the last one's C, it has the same width as B, and that's because the standard deviation is 0.7, but the mean has slid to the left. The mean is now at 1.5, and so it's going to go to 1.5 on the number line. These are not standard curves. We'll get to those in a few minutes. Now the inflection is where it kind of starts to change. And so we'll look at some problems in a minute because that's a little more confusing. So in our homework, you're going to see problems like this. They gave us two curves. They gave us B is right here and A. So notice A is taller and B is shorter. B is more spread out and A is more normal. More narrow. And then they also have different means because mean is, you want to look at the maximum point. So for A, the maximum point is way up here. And then if you go down, you'll see that the mean is sitting at 15. For B, if you go to your maximum point, which is right here, this pen is driving me crazy, and go down, you'll see that the mean is sitting at 12. Therefore, if it asks you which curve has the greater mean, that would be A because the mean is 15. Now, they didn't tell us the standard deviation, but we can see that B is more spread out. And so B would have the greater standard deviation. All right, so let's look at another one. So this time we have A, B, and C. You can see that A is the tallest, then B, then C. So C looks wider. B is wider than A, but not as wide as C. So the first question is who has the greatest mean? So remember the mean is that you look at the the greatest point. So for A, that would be sitting right there, and then come down to your number line. Looks like it's about at 45. And C is the same way, right? C has the same mean. It has a different standard deviation, but it has the same mean. Now B, the highest point is right here. So if we come down to the number line, you see that the mean is 60. So the curve with the greatest mean is going to be B. Now, when we're looking for the greatest standard deviation, that's when we look for the width. And so of these three, C is the wider of the three, and so it has the greatest standard deviation. We've used this formula before where we do a z-score. So a z-score is when we take the value minus the mean and divide by the standard deviation. It's always going to work this way. This will be on your resource sheet. I'll make sure you guys all have the resource sheet. We're always going to take the data value, subtract the mean, and divide by the standard deviation. This will give us a z-score. So this is how we turn the number line into a standard normal, where the mean is going to be 0 and the standard deviation is going to be 1. This is also from the book. I just want you to notice that in the middle, the mean is 0. That's because we used a z-score and we changed whatever the mean was, whether it was 60, whether it was 500, doesn't matter what it was. We changed it using the z-score, and it is now 0. Each tick mark will be by a 1. And so right here will be 1 standard deviation away. Here at 3 would be 3 standard deviations away. And those are greater than the mean, right? So 3 standard deviations greater than the mean. If we go the other direction, if we're sitting at -1, we are 1 standard deviation less than the mean or to the left of the mean. Still, the area is going to be equal to 1. And just like with probability, it's going to equal 1. But if we talk about percents, that's going to be 100%. Now I know that this looks like craziness, but we are not going to use these tables. This is how we used to find the area under the curve back when I went to school, when I rode my Tyrannosaurus Rex to school every day. We had to have these tables, and we had to have books with tables, and none of that anymore. We're going to use StatCrunch. So this first problem asks us to find the area that corresponds to a z-score of 1.15. So 1.15 is sitting right here on my number line. So it's a little more than 1 standard deviation away from the mean. Now, if they don't give you a mean and a standard deviation, that means it's been standardized and we have 0 as the mean and 1 as the standard deviation. Also, if they don't tell you which direction to go, if they don't tell you less than or to the right or to the left, it's always going to be to the left unless they state otherwise. So for us, we would have to go to this table. We'd have to remember that it's always to the left on the table. We're not going to worry about that. The next screen is going to show us how to do this on StatCrunch. So we're going to remember a z-score of 1.15. Okay, so when we have a normal curve and we want to find the cumulative area under the curve, we are going to go to StatCrunch. We're going to go to Stat, which we're used to. We're going to go to Calculators, which we're used to, but we're going to come down here to Normal. We have done that, I think, before. This might be new to us. So what we're going to do at this point is we're in the Normal Calculator. You want to make sure it says Normal Calculator up here. And then we want to make sure that the mean is 0 and the standard deviation is 1, unless they've given us the mean or standard deviation. We'll get to that later in the week. So right now we want 0 and 1, and then we're going to tell the StatCrunch which way we want to go. We want to go to the left. Therefore, we're going to use a less than or equal to sign. And remember, the problem gave us a z-score of 1.15. So basically what this is telling me is that I want all the area to the left of 1.15, which is sitting right here. And what's really nice about StatCrunch is it gives us a picture. And so we can see if this picture matches what we think the problem is, or if the problem gives us a visual, we'll know. At that point, you're going to hit compute. And when you hit compute, it's going to give you the area under the curve. Therefore, what's happening here is all of this area under the curve, all of this is equal to 0.875 if we round. So it's about 87.5%. And that's the answer. That's what they're looking for. So let's look at the next problem. This time they wanted the cumulative area that corresponds to z equals negative 0.24. So I drew a picture up here in the corner. You can see that the negative 0.24 is sitting right here, just to the left of 0 on the number line. And we want the area under the curve. It did not tell us which direction to go, so we're always going to go to the left. Again, we're not going to use this table. I'm just showing it to you so that you can appreciate what I used to have to do. We're going to use StatCrunch. So let me move to the next slide. Okay, so here I am in StatCrunch. I went to Stat, Calculator, Normal. I made sure that 0 was in the mean, 1 is in the standard deviation. I want to go to the left, so I use less than or equal to. And this time my z-score is negative 0.24. And look on the graph, you can see that it moved, it slid my area over to negative 0.24. So now if I hit compute, I'm going to get the answer. And for this one, it's going to be 0.405. So about 40.5% would be all of this area that's under the curve.